All right, well, it's time to officially begin chapter 4 in our textbook. I hope this brings you as much joy as it brings me when I do this stuff. I actually quite enjoy this kind of mathematics. I find it very intriguing and fascinating, and I hope to buy you in on some of the fun of this all. So we're beginning this unit which is all about counting. So something we've been doing since we were little children, and yet we're going to develop this into much more complex and interesting kind of counting situations. Okay, so while I was gone, we worked on Pascal's triangle and we did applications of Pascal's triangle. So we kind of skipped ahead in chapter 4 from our textbook. We're going to come back to the first few days at this point here. Okay, so provided some formulas. These are all the formulas you would need for chapter 4. There's not really a lot of formulas. It's more of an idea base, and it's all things you kind of know from before, but you got to apply them in really creative and interesting ways. So today I'm challenging you to try and pause during my lessons and to actually try out questions. Okay, so the first skill I really want you to learn is how to list all possibilities. So for example, number 1 here, if you flip a coin 2 times, how many different possibilities are there? And let's list every possibility. So a coin has 2 options. It's either a tail or it's a head. So it could be heads, and then you could get another head. That would be one option. You get a head, and then you could have a tail. So that's all the options when you begin with a head. You could also have a tail and then a head. And then you could have a tail and then another tail. And that's all 4 possibilities right there. Okay? Well, what if I decided to do some game where I was flipping a coin and then after that I was going to roll a die? How many different options would there be? So option 1 would be you could roll a head and then you could get a 1. You could roll a head. Flip ahead and then roll a 2. Now keep listing all the possibilities. Remember that a die goes up to the number 6. Pause the lesson, come up with your answers. Okay, so here are all the answers. Tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So those are all the possibilities. And being able to actually list them all out is a skill that's important before we go into just figuring it out using numbers and randomly multiplying and all these different things. Okay, what about if you roll a die 2 times? How many different possibilities are there? So I want you to work through this one, and I will show you the answers later on. Okay, list all possibilities for that one. I know it's a bit of a pain, but do it. Pause the video. Okay, now let's go back to number 1, and let's try out B. Make a tree diagram to represent all the possible choices. So I know I'm not following my instructions, but let's try it anyway. So option 1, you flip a coin, and on the first flip, you either get a head or a tail. On the second flip, you can think of this as flipping a head or a tail, or a head or a tail within each one of those. So notice that this line represents head, or this line right here represents a tail and then a head. So that's this one right there. Okay? Try that out for number 2. See if you can make a tree diagram of all the possibilities. And again for number 3. And when you get to number 4, I want you to try that out as well. So just make a tree diagram of all possibilities. And number 5, do that for rock, paper, scissors. For this one, I'll get you started on this. You're thinking about whether you win or whether you lose in the game of rock, paper, scissors, not whether you put out a rock, a paper, or scissor. Okay? Again, answers will show up later on. All right, now that you're done that, the above assignment, as you were told to do, so listen to me. Now we're going to go to a bit more of the lesson for today. So organized counting, it's simply put, it's combinatorics, is counting. It's just counting. It's that simple, but yet it's a university branch of mathematics. It's a branch of mathematics that involves a process of counting complex situations, and applications can be found with license plates, with telephone numbers, with postal codes, with travel itineraries, with coloring and map problems. Really, the possibilities are quite endless and quite interesting and fun. And in this, well, it's not a slideshow. In this sheet, you are introduced to many complicated tasks. What will be important is your attitude, your creativity, and your diligence in finding the solution. So problem number 1 here. Lucas has a spinner with 2 colors. It's got red and a black side. He spins it 4 times. Calculate the number of different orders in which the spinner could land red or black. Draw a tree diagram to illustrate all possible results. Do you get the same answer? So I'm going to leave it to you to try and figure out how many different answers there are and to list them all. But I'll give you the hint that the answer here is 16. Problem number 2. In a school store, the profit is best if a student selects a drink with their hot food item. On any given day, the store has 4 hot food options and 8 drinks for sale. How many different combinations are available if the person buys only 1 drink and 1 hot food item? So this one, I find it nice, and I'll do this question with you in full. So there's 4 hot food items. So let's call them 1, 2, 3, and 4. These are the hot food items. Okay, and then drinks, we'll call them A, B, C, D, E, F, G, and H, because that would represent 1, 2, 3, 4, 5, 6, 7, 8 different possible drinks. Okay, so how many different combinations are there? Well, if we look at this question, what you can think of is if you're standing in line and you're thinking about, ooh, how many hot food items, you have 4 options there, right? And then when you're thinking about the drink, you have 8 options there. And you can think about it this way, that if you choose hot food item number 1, you could have A, you could choose B as a drink, you could choose C, D, E, F, G, H. And so notice that there's 8 options just within the hot food item number 1. And if you were to choose hot food item number 2, you would also have 8 options and 8 options for 3 and 8 options for 4. So notice that every time you're doing 8 options. So that would just be the same as saying 4 times 8, which gives you 32 combinations. Okay? Problem number 3. At Trent U, education students in the Bachelor of Science program take 5 courses each year. There are requirements, biology, chemistry, and math, so they must do this. Biology, they must do chemistry, and they must do math. But students pick between one of anthropology, psychology, or sociology. And then their 5th course, they get to choose one of 25 arts courses. So how many different combinations of courses are available to a Bachelor of Science student? So pause the video and see if you can use the question above, number 2, to solve problem number 3. Okay, so now that you've joined me back again, first of all, you have to take biology. So how many options do you have? 1 option. Just take it. You have to take chem. So 1 option. You have to take math. Of course you're going to take math after this great high school experience. And that's 1 option as well. And then you have the ologies, we'll call them. Okay? Because it's anthropology, psychology, and sociology. And there you have 3 options in there. Okay? And then for the arts course, you have 25 options. So in total, you have 75 options for your year. Okay, problem number 4, I do more as a fun opportunity to see where we're going to go. This won't be really tested today in your work, But visually impaired people are traditionally taught to read using the Braille system, where 1 to 6 dots are raised to make a bump on the paper. How many different combinations of Braille lettering are available for use? So just to give you a picture, there are, let's see if I can get this right. It's a really funny way of drawing this, but okay. Each spot here has an option. So you could have this spot raised, and that would be a letter. You could have this spot and that spot raised, and that would be a different letter. So there's all these different options. So how many options are available? Just try it out for a minute, see what answer you can come up with. Okay, now that you've tried it and you paused the video as I asked you to do, the answer is 63. Now let's see if we can come up with the reason as to why it is. So if you think about it from a physical perspective, this spot right here, number 1 here, has 2 options. It's either going to be up, raised, or it's going to not be raised. So it would have 2 options. Top right spot also has 2 options. And we have 2 options, 2 options, 2 options, 2 options for every single spot. So you'd have 2 to the power of 6, which is 64. And why did I tell you that the answer was 63? Well, simply, it would be that if you have nothing raised, you don't have a letter, you just have a flat piece of paper, which is like every other piece of paper. So not having a raised position is not a letter. So we take off 1 for having no raised dots, okay, which gives us 63. All right, and our last question. How many different ways are there to either roll a sum of a 5 or 8? So what I want you to do with 2 dice, by the way, okay? So come up with every option that gives you a sum of 5, and come up with every option that gives you a sum of 8. Pause the video and try this out. Okay, the answers are, for 5, 1 and 4, 2 and 3, 3 and 2, 4 and 1. And for 8, it's 1 and 7, 2 and 6, 3 and 5, 4 and 4, 5 and 4, 6, 5 and 3, 6 and 2, 7 and 1. In case you're wondering, yes, I made a mistake on purpose. A die does not have the number 7 on it, so you can't get a 1 and 7. That's ridiculous. Okay? The natural question that comes up next is a 3 and a 5 different than a 5 and a 3, or a 6 and a 2 different than a 2 and a 6? And the answer is yes, and there's a history to this and people having to figure this out, and at first it being done incorrectly. But if you tried it out, if you rolled the die 1,000 times, you would find that the probability of getting certain things would result in 5 and 3 being different than the 3 and a 5, and it would just add up. It's a really kind of messy thing. What I want you to think about is, think about this being a red die and this one being a blue die. And if the red die had a 3 and the blue die had a 5, that would be a different picture than if the red die had a 5 and the blue die had a 3. So then the next question, of course, is, well, what about the 4 and 4? Wouldn't there be another 4 and a 4? Well, if we switch the red die to a 4 and the blue die to a 4, we actually didn't switch anything, so nothing changed. So a 4 and a 4 is not different than a 4 and a 4. But a 3 and a 5 is different than a 5 and a 3. Okay? All right, so the question was, how many ways are there in total? So here we have, there are 4 ways to roll a 5. And there are 5 ways to roll an 8, which gives us 9 ways in total. We don't think of that as being 4 times 5, which gives us 20 ways. These are mutually exclusive events. You either roll a sum of a 5 or you roll a sum of an 8, and so there's 9 ways. So the concept for today is if a problem has stages with separate choices, M, N, P, etc., you multiply the number of choices from each of the stages. The number of possibilities is M times N times P, and you can keep going on. Example, if you choose 13 cards from one suit and flip a coin and roll a dice, there are 13 times 2, so it's 13 cards, right? There's a coin, which has 2 options, and there's a die, which has 6 options, which gives you 156 ways to do both. Problems numbers 1 through 4 today. So Lucas and the school store and Trent University and this visually impaired question, the Braille question, all of these are multiplicative. Mutually exclusive events are exclusive if they could not possibly occur at the same time. So they cannot. Example, rolling a dice and flipping a coin. Being a calculus or data management student is not mutually exclusive because you could be in both classes, and some of you are. The additive principle, if you choose from either M items of one type or N items of another, then the total number of ways to choose an item is M plus N. And the problem number 5 is considered additive. We could change one of these questions to become additive, and that would be the school store question. Let's say that I said you could only have a hot drink or a hot item or a drink, and you can only choose one thing because you only had enough money for one item for that day. Well, if you only had one thing you could buy in total, you would have 12 options here. That's 4 plus 8. Right? Because you could only pick either hot item 1, 2, 3, or 4, or drink A, B, C, D, E, F, G, H. Okay? Whereas on the flip side, this one says the question's different because you're choosing a hot food item and you're picking a drink. So now you had 2 things that you could choose from. Okay, so that ends the lesson. I will put the answers on Edsby to all of these questions here so that you can check your work. Have a fun time practicing.